Professor Seco, the stage is yours.
Great. That's great. Thank you. I have a question for you. If you think of the 20th century, what do you think is the biggest achievement from a technology perspective? It's a very large room. I cannot hear your answers. So it's more of a rhetorical question. So I'm sure what your answer was very interesting, but I couldn't hear it. So I have some reflection. Let me argue that the biggest achievement was to send the man to the moon. Okay, not the woman, the man. We've learned a few things since then. See, if you want to go 1 century before, you would say in the 19th century, very likely the biggest achievement was the train. Okay, you can argue when was electricity considered to be achievement. These are interesting reflections, but the reason I want to talk about this is because if you think of the 20th century, technology in the 20th century is characterized, in my opinion, by 3 characteristics. The first is very small data. If you think of the exercise of sending a rocket to the moon, the amount of data that you're working with is very small. Gravity, some data about some materials, the density of air, the distance to the moon, and very few other things. You can write down your data set with your hand. Another characteristic is lots of equations. The big achievement of NASA implied that there were these very long computer programs. The computer was another big invention of the 20th century, but it was mostly used for these things. Computers were used to implement equations, the equations of motion, and it managed to send the people to the moon. And then finally, most of the inventions happened in physical space, okay? You are here, moon is there, we go from here to there. A lot of the 20th century was like that. Now, if I want to think about the 21st century, things look very different. On the one hand, we have lots of data. Data is being accumulated and stored all the time. Sometimes we don't have access to it, it's just there, right? All of your smartphones are collecting data by the second, and that goes somewhere. At the same time, we now live in a world where there are no equations. Most of the things that happened are our approach to understanding them is, let me look at the data and let me figure out what the equations are. And finally, everything happens in mental space. Very different, the way the 21st century is behaving from the 20th century. And it's very important to understand this difference, otherwise you're going to be at a disadvantage. You're going to be 100 years behind. Very important. I'm a mathematician by training, and it's very important for me to realize, most people think mathematics is about equations. You may have been punished with a lot of equations during your math education. Math is something different, okay? And in fact, if I talked about math, I will do a similar analogy as to how mathematics became free of equations with the work of Poincaré at the beginning of the 20th century. That's a different story. So today I want to focus on this perspective, and I want to start, I want to go back in history as far back as I could to the work of Ptolemy or Ptolomeo, I don't know how you say that in your language. And he did something very interesting. It's the earliest account I have for what I call data science, or in a certain sense, he was the first example of not machine learning, but perhaps data science. He did something very interesting. Before him, Aristotle came up with the theory of the Earth and the planets, and he made a beautiful theory. Beauty was still a criterion for truth back then. If something is beautiful, it's probably going to be true. So his theory of concentric circles with the Earth at the center is what Aristotle did. But then people saw, Ptolemy was one of them, that this theory was not consistent with observations. The planet Mars on occasions did something that was just not explained by the concentric circles. So what Ptolemy did is create a new theory out of nowhere that would aim to explain what you see. Okay. I would argue that a lot of the data science that we have is the same attitude at an enormous scale. Okay. So this thing has been happening through history. And today, what I want to do is I want to see how all of this can be applied to perhaps what's considered today to be the biggest challenge that we have as humanity, which is represented by the 17 Sustainable Development Goals of the United Nations. So it's not about going to the moon, it's about managing our water resources, dealing with climate change, poverty, and so on and so forth. These are very complicated problems. There are no equations for these problems. The problems are real, we see them, and we're looking for solutions. What I want to discuss today is how data science is perhaps a way to approach these problems going forward. And I want to, my training is in finance, and finance is at the core of many of the solutions. Article 2.1c of the Paris Accord for Climate Change states that finance will be the driver for a lot of these solutions. We work in a situation that if you drop some money somewhere, then that's where people go. So based on that, finance is perhaps going to be part of the solution. And I want to, in the expression of that, I want to go back to this event of May 24th, 1990, when Harvard University made a very surprising decision. Their decision was to divest from tobacco stocks. I don't know who was born before 1990. I was. And back then, when you heard the word divest, it all had to do with apartheid in South Africa. And here comes Harvard University and makes a very surprising decision. They're going to divest from tobacco stocks. And the reason is listed here. The reason is that they thought it was an unethical business. And it's a very large endowment, and it's a very influential endowment. So their decision to divest from tobacco stocks made a lot of people think what investment should be about, because investment was considered to be about making money. And the tobacco industry was an extremely profitable industry. There was a sentence going around saying that they make a product for a penny and they sell it for $1. That's a tremendous profitability. Hedge funds were fighting each other to buy the tobacco companies, and then suddenly Harvard University decides, you know what? I don't want to be part of that. And this has led to, in the 21st century, to some reflections and some reviews, some modern approaches to ethical investing, and to figure out what it is that you want to do with your money. And if now I go and I review 100 years of investment decisions, perhaps I would say that investing the way we know it today started about 100 years ago. And 100 years ago, if you try to imagine how people did their investing, there was no data. Or actually, that's not true. There was data. This is when accounting standards were introduced, and actually financial regulation required companies to publish correct accounting statements. So there was data, there was reliable data, It's just that it was in very small amounts. All the data that was available to you was on a piece of paper. There were no computers. Computers came in the 50s, and in the 50s was the beginning of a different type of investing, and very quickly that developed into the use of time series to understand investing, all fueled by the computer. And databases started, and data-driven investing was born. But now, I want to reflect on how financial decisions are made. They are made very much like Harvard decided to divest from tobacco stocks. There's a social element in how investment decisions are made. I oftentimes like to use the example of GameStop. Are you familiar with that stock, GameStop? It went back in the news, I think it was last week. Again, it went up by 100% in one day. Yeah? Are you familiar with the stock DJT? Donald J. Trump, the media company? Okay, are you following that? So if you try to understand those stocks from a 1930 perspective, it doesn't make any sense. And in fact, it doesn't make a lot of sense for many of the people in finance, and the reason is that they think 20th century. They don't think 21st century. A lot of these decisions are driven by other things which are not encoded in companies' financial statements. And you need to be aware of these things. Now, that's when it comes to the world of investing. But if I focus on data, what we're seeing is a very deep change in decision making. And even from a data perspective, data has traditionally been numerical data. When you talk to most people about data, they think data is numbers. They've been numbers for a long time. Since 1950, the creation of the first computer, databases have been numbers. But now the most interesting databases are text. And the reason ChatGPT, for example, works is because we have now access to other databases, which are text. If I ask you for a choice, it's an unfair choice, but if I ask you for a choice of numerical data or textual data, which one do you think is more interesting if you're given a choice? It's an unfair choice, I know. There's a lot more data in textual data than in numerical data. Okay, imagine that we were able to record everything that I'm saying here, and imagine we were able to record everything that you are thinking about what I say here. That beats any numerical data, but it's all text. It's all text. And that's where we are. And a lot of the revolution that we are seeing is because finally we are able to deal with textual databases. That's where things are changing so fast. It is very difficult to overstate the transition we're going through simply because instead of numbers, we can now deal with words. It's changing everything. ChatGPT is just an example. There's going to be many more things to come. But just wait, because now, very soon, we're going to have sensor data. I don't know if you saw this. I saw it in a very fast piece of news. I didn't have time to do any fact-checking. But you may have seen that there was an article somewhere that pointed to a patent application, I think by Apple, that the new earphones are going to be full of sensors to detect all sorts of activity around your ear, your brain, stuff like that. And this is data which is going to be produced, stored every second. And that's going to have a tremendous impact. We're not there yet. We're coming to that. And once we add to that all the data that's going to come from images, video, and similar things, just get ready because the changes are going to be tremendous. This is already having a big impact on agriculture, for example. The fact that you can now use drones to very quickly scour large areas of, for example, plantations and figure out which ones need water, which ones have diseases need to take care of. You can do this in real time. So the changes that we are seeing are very deep, very, very deep. And if I now go back to the problem is, let's forget about agriculture. Let's forget about finance. How can we use this to make, to solve the sustainable development goals? Well, first, if you're trying to deal with hunger, agriculture is going to be a very important part of that. Water management is going to be a very important part of that too, because now we have sensors that will give us information about water in real time, either from satellite images or from drones, or just sensors that you put on the ground. Then we might be able to effectively manage, for example, groundwater. 99% of the world's fresh water is groundwater, and we're having problems with it all over the world, and climate change is probably going to make those problems worse. Is that something that we can tackle? The answer is yes, and there is already in the financial sector something called ESG. It's been going on for a few decades. It's extremely imperfect. It's extremely imperfect, mostly because there's no data, at least not proper data to do that. But if we were able to do data, we would be able to do some analysis of where money should go, which is the way you favor certain decisions versus others. What you have here on the screen is one way of analyzing the decision that Harvard made in 1990 using modern technology. This is done with the company of one of my partners. We've done some papers that I'll talk about today. His company can produce this. You give him the name of a company, say a tobacco company, and then it will tell you through history how this company impacts the things that matter from a sustainability perspective, whether it's impact on the environment, on social justice, or anything you want. We're able to answer those questions. This is remarkable, okay? Go back to 1990 and Harvard's decision, no tobacco stocks because they kill their customers. That's a very, compact sentence. That can be turned into a diagram that will tell you over time how companies score based on any criteria that you have. And this is all powered by word textual databases. This is already here. This is a very efficient use of large language models, for example. But perhaps I want to play a game and to tell you some of the challenges that we face. You may have seen this game before. If you look at, I'm going to play two games with you, okay? And I want to do a show of hands, see if you are like most audiences, okay? There's a theory about this. Let's say we play this game, and I give you two choices. Choice A is you're going to make $900 for sure. I give you $900, you go home. Choice B is you're going to gamble. With a 90% chance, you're going to make $1,000, and with a 10% chance, you're going to make nothing. Okay? Who would choose A? Raise your hand if you choose A. Yeah, that's it. You're like normal audiences. Raise your hand if you choose B. Yes, you are like normal audiences. There are some risk takers there who would like to do that. Great, perfect. Let's now play this other game. With a 100% chance, you're going to lose $900. But I give you a choice to gamble, which is with a 10% chance, you go home free. But there's a 90% chance you'll lose even more, $1,000. Okay, so let's play this game again. Let's see if you are like normal audiences. Who chooses A? Yeah, you are like normal audiences. Who chooses B? You gamble, okay? Great. So there's a lot to say here. Let me pick a topic that everybody's talking about today. Climate change, for example, okay? Climate change is what kind of a game? Is it game number one, game number two? Scheme number 2. Okay, I'd say ignore the risk. Okay, just go home. Or I give you a choice. You say, well, there's a risk that something bad is going to happen. Why don't you pay some money? Okay, let's make changes to society. It'll cost us money, but then there's a chance. We don't know if what climate risk is going to do to us. Some people say it's going to be very bad. Some people say it's not going to be so bad. Let's say that you're not an expert and you're not sure. Okay, would you gamble? And that, well, most people say, you know what? I will gamble. In a situation of risk, which is what we have on the right-hand side, people choose to gamble. And this is part of the reason why it's so hard to deal with a lot of these sustainable development goals, because if people say, you know what, you can pay up now or you can pay up more later. People say, what? I pay later, even if I have to pay more, even if I have to pay several orders of magnitude what it'll cost me to do things now. This is very well known from behavioral economics, and it shows why it's so hard to convince people to do what, from a game one perspective, seems to be the right thing to do, doesn't it? Okay, now I'm not going to get into psychology. Psychology is extremely interesting, and it's something that you can also do with data science. But let me ask you a question. What do you think a machine would do? Depends how you train the machine. But if you used algorithms to make decisions, it's very likely a machine would say, you know what, I don't care. Game 1 and game 2 are the same to me, right? And very likely a machine is going to be more objective in making the right decision going forward. So this is perhaps a reflection of how hard it's going to be to deal with a lot of the changes that we have, because it's going to cost us money. That's what Harvard University did. They gave up money not investing in stocks because they thought, you know what? I don't know what's going to happen to tobacco companies, but I just don't like those odds. I don't like to take those risks. By the way, you probably know what happened to tobacco companies after Harvard decided to not invest. They started to get lawsuits, and they systematically lost every lawsuit from everybody who ever had cancer, respiratory problems, or anything. So perhaps what Harvard was doing was not just ethical, it was also smart investing. Yeah? So given the fact that the Sustainable Development Goals are going to cost us money, the way we play this game matters a lot. So there's something else, which is how trade exists. If you think of how disagreements between people are resolved, if you are political disagreements, you vote for party A or for party B. But when you have financial disagreements, those are very easy to resolve. You just trade. You think this is too expensive? You think this is too cheap? Okay, you buy the cheap thing and you sell the expensive thing. If you're wrong, you'll lose money. If you're right, you'll make money. That's how trade exists, right? So these advantages that finance has that other parts of our daily lives don't have, which is how easy it is to trade risk. And this was done for the first time by Hammurabi. Actually, it was encoded in his code of Hammurabi. This is how the insurance sector started. We're talking about almost 4,000 years ago. And today, this is expressed with Article 2.1c in the Paris Accord. It's the same thing. Article 2.1c in the Paris Accord is expressing in climate terms how the exchange of risk is going to happen. Okay? And governments will be facilitating the development of this. So in understanding this situation, there's a very important role for data science to do. And this is the part that I'm talking about, the science fiction. We're talking about the parts that we don't yet understand. And that is the dependence structures, the relationships. I'm going to use some technical terms, but I want to tell you why. The challenge we have now is we are able, through data structures, to understand what's called association. What is related to what, or what happens at the same time as what? Yes? For example, if I told you that most people die in hospitals, okay, what would you do if you're sick? Would you say you go to the hospital to die, or you would stay home and be safe? If you follow your association metrics, like, for example, correlation distance, I have some others here, or even advanced things such as regression trees, what would you do? Would you stay home? Some people will stay home and say, I don't want to go to the hospital to die, right? But why is that the wrong decision? Well, you know, because you know what's called causality. I'm just going to fast forward to causal dependence is what makes us make those decisions. We know that going to the hospital is good for you. You know that the reason people die is not because they went to the hospital. That is just what's called an association. I have a data set that says all these people went to the hospital and these people died. Most of them died after going to the hospital, but not because they went to the hospital. Learning that from databases is the current challenge that we have. When you look at for example, climate change, there's a lot of arguments about the observations that we have. Last year was the warmest year on record. And then some people say, well, I've seen that before. 100 years ago, something similar happened. We really don't know what is causing what. And then we do see the associations. And we have a lot of arguments that if you understand my metaphor, people are saying, I'm not going to the hospital to die. And people say, no, 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 you go to the hospital because that's how you don't die. And then people say, no, I look at the numbers and that's not what the numbers say. And then people say, no, you're looking at the numbers wrong. And a lot of this discussion is all about data. And that's because we don't have today still the right tools to analyze data from a causal perspective, not even ChatGPT. Okay? There's a very interesting question you can ask ChatGPT. I think ChatGPT has learned since this question became well known, but if you ask ChatGPT the following question, this is the question. You know ChatGPT, yes? Or Copilot, yes, okay. You ask ChatGPT, I went to the movies at 5 p.m. and I had dinner at 10 p.m. Was I alive at 7 p.m.? What's the answer? You know the answer, right? ChatGPT doesn't know the answer. There's something missing there. Causal relationships are very hard to understand. We're beginning to go there, and I believe that when we have causal structures that help us understand when A implies B, everything will change. And in particular, perhaps at that point, a lot of the arguments about climate risk or water management or other things will be resolved. We may have the data, which we don't have now. We may have the right causal relationships. What I'm going to show you now is a way to deal with this that I have done. It's in a slightly different situation. We have a way to, this is all about association, and this is a way to understand how data relate to data. It's still association, and we have very sophisticated models to understand that. We put this to use. I'm just going to go quickly through these things. We use this to understand how you can do proper investing, but all of this is based on association. This is not right when you try to understand real problems. So when you come to for example, climate risk, climate risk is a fairly simple risk. It's all about emissions. You know about climate risk. Certain chemicals are warmed by the radiation that comes from the sun. One of them is water, for example. Water vapor is one of the most potent greenhouse gases, but the thing is that we have rain, so when there's too much water, it just goes away, right? But CO2 stays there for a long time, more than 100 years. Methane is worse, but methane oxides quickly, so it becomes CO2. So there's this accepted metric of what leads to global warming, okay? And we think it's CO2 or equivalents. And this is what some people do. Say, well, CO2, okay, let me see who is the biggest producer of CO2. And of course, when you do that, the country that is the biggest producer of CO2 is China. Okay? Okay, what's the conclusion you get from there? Well, China is in the news very often. Oh, it's China's fault. But let me argue, well, China is the biggest country, right? So why don't we do emissions per capita? Some people do that too. When you do emissions per capita, Canada shows up pretty high up. And why is that? Because Canada is a country which is mostly empty, and a lot of the emissions come from agriculture, has nothing to do with people. So this is another interesting way of interpreting your data in the wrong way. I'm not going all the way to causal, but even from an association perspective, I know that this is the wrong way of looking at the data. And if you keep on looking at the data and making judgment about emissions with arguments like this, you're going to go to the wrong place, guaranteed. Guaranteed. So what is the right way of understanding emissions? If you want to understand who should be reducing their emissions and who is below their emissions budget, these are things that are discussed. In the Paris Accord, countries have their own self-imposed targets for emissions, okay? How they arrive at those numbers, I don't know. But let's be scientists, let's be data scientists for a minute and say, if we want to reduce emissions, what should the right numbers be for each country? How can you do that? Shall you divide by the number of people? Shall you divide by the number of cars, buildings? Well, what's the right? The thing is that division is not the right way. We happen to know what we think is the right way, and this is a result that we obtain. We call emission benchmarking. And this is, again, just the first baby steps in understanding this. So we came up with techniques from data science to understand what emissions are really due to. Population is one, but surface area is another one, and other things. And when you do that, you put them all together. Let me just go to the result. You can have these very interesting graphs by country. I can tell you which countries are producing more than their budget should be and which are producing less than their budget should be. This is a consequence of feature engineering that you may have heard. Okay, we need to figure out what the features are. And then I'm not going to name countries, that's not the purpose. I don't want anybody to be embarrassed, that's not the point. But this gives you a very level-headed way of understanding what emissions really are and when the emission of a certain country is actually high or not. Okay? As opposed to just looking at the absolute numbers or dividing by random features such as population. Okay? So this is, I think, the beginning of a rational approach away from game one or game two and making the right decisions. If this turns into a policy or policy making, whether it's in the United Nations or in individual governments, so be it. But we need a framework that uses data as the input that leads to the right decisions, okay? And so that's one. You can see countries that are becoming browner and countries that are becoming greener. And this is done from a data science perspective without any, in a completely dispassionate form. Okay? This is just what the data says, no more. Okay, and I'm going to end my presentation talking about perhaps the beginning of what is really important, which is causal discovery. I'm sick, so I go to the hospital. The data says I should stay home. Yes? Okay, so to do that it's a paper that we have done here. The way to do these decisions is through directed acyclic graphs, DAGs. A graph is just a decision tree. Okay, shall I stay home? Shall I go to the? What are the factors that drive this? I have some nomenclature here. I'm going to try to skip through that. I just want to show you what we do and how we use ChatGPT to make the right causal discovery. This might be useful, for example, for climate. Okay, if I have the ability to give the right prompts to ChatGPT, I might be able to know exactly what causes what. In other words, if I go back to the problem of shall I go to the hospital, you can ask ChatGPT, shall I go to the hospital? I'm sick. But that prompt is likely, I'm not sure if it's going to give you the right answer, but if you're able to understand what features are, you have to give more details to ChatGPT. I have a headache, I was run over by a car, something happened to me, And then with that, by analyzing textual data, you might be able to get the right causal relationships. Causal relationships are given by graphs. And this is something that we did using feature cluster engineering. I'm going to skip through how we did it. I'm just going to go to the end because in my religion, I cannot go over time. Okay? So I have 3 minutes left. I'm going to finish in 1 minute, so I'm safely away from my limit. Okay? So in doing that, we have several steps: causal exploration, causal inference, and then this leads to the creation of our graph. And this is a new type of doing feature engineering. We try to understand what features imply what. Okay, and we do that with graphs, first with feature clusters, and then with individual features. This is what the typical relationship looks like. I have an example that I'm going to show you next. This is the sample of a prompt that we use with ChatGPT to understand what causes what. We had to do a number of these to understand what causes what. Okay. Again, think of the example of going to the hospital when you're sick. And then finally, you get a graph like this one. This is applied to credit risk. So you go to the bank to ask for a credit card or a mortgage. Right now, the banks, they're getting smart, but the banks still, many of them go through the very old-fashioned process. How much do you earn? Do you own or rent? This and that, and then they make decisions. The thing is that if they have access to a lot more information from you, and in Canada, one of our most interesting banks actually owns a supermarket. So they can ask you questions. Actually, they don't have to ask you. They already know. Like how much milk you buy, for example. They already know that about you, right? So is that relevant to give you a loan? The process of giving loans is very interesting. So you can have a discovery graph like this that you know what implies what. It could look like that, or it could look like that. And this is what causal discovery will do. We apply this to credit. We haven't applied it yet to sustainable development targets, but that I will save probably for the talk next year. I hope to have it by then. Thank you very much.